In this tutorial, we're going to take a look at the method of substitution, and I'm going to work through two examples. And after I do each example, I'm going to show you graphically what the substitution method looks like graphically as you're doing the substitution. Okay, so we'll take a look at that at the end of each of the examples. Now, substitution is a method for solving systems of linear equations, and it's more a little bit better method than elimination, perhaps, or at least as good. If one of the coefficients, at least one, is either 1 or -1, or you have an equation already solved for x or y or whatever your variables might be. See, the second equation is already isolated for y or solved for y. The first one could be isolated for y fairly easily because there's a 1y here too. Okay, so in both those situations, substitution is a reasonably convenient method to use. So what I'm going to do first here is, since the second equation is already solved for y, I'm going to take my first equation, there's my first equation, and what I'm going to do is I'm going to substitute this, since that is what y equals, I'm going to substitute it in place of y here. So I'm going to now rewrite this, but instead of writing y, I'm going to write 2x plus 1. So this is what it's going to look like. So there's my 4x, and in place of y, I'm putting the 2x plus 1 here, and then equals 7. So now what I have is an equation that has just x's in it, so I can isolate for x. I can solve for x. So we can add 4x and 2x together. That's 6x plus 1 equals 7. I want to isolate for x, so the first thing I would do is isolate the 6x, get the 6x alone. So let's subtract 1 from both sides to get rid of the 1 here. See, the 1 is added to the 6, so the opposite of adding 1 would be to take 1 away. So that's 0, so we would just have 6x on the left would equal 6. Now, this tells me that 6 times x is 6. I want to know what x is, so I want to get rid of this 6. It's multiplied by the x, so I would divide both sides by 6. See, this divides out. 6 divided by 6 is 1, so that just leaves us with 1x on the left, and it equals 1 because 6 divided by 6 is equal to 1. Now that I know what x is, I want to use that to find what y is. So I'm going to take this second equation, and I'm going to substitute the 1 in place of x here. So y would equal 2 times 1 plus the 1. And 2 times 1 is 2, plus the 1 gives us 3. So it looks like x is 1 and y is 3. So I'm also going to show how to check. So to check, what you're doing is you're substituting the 3 and the 1 for y and x into the equations, into both of them, to make sure it makes each one a true statement. That means that the point is on each of those lines. So the 4x plus y equals 7, the left side expression is the 4x plus y. So I'm going to write LS stands for left side, 4x plus y. So I'm going to put 1 in place of x here and 3 in place of y. So 4 times 1 is 4, plus 3 is 7, and 7 is what's on the right side, so that equals the right side expression, so the point is definitely on that line. So we also need to check with the second one. So the only thing to evaluate is the 2x plus 1 on the right side, so this is the right side expression, the 2x plus 1, so my 1 is going to go right over here. 2 times 1 is 2, plus 1 is 3, and you see what's on the left side is the 3, because if I put 3 in place of y here, that is the left side expression, the same thing. So the solution is x equals 1 and y equals 3, or we could also say the lines intersect at 1, 3. I'm going to show you that now using Desmos. And I did not mean to do that. I'm looking for this. Here we go. Okay, so here's my graph, and just to verify, you can see that 4x plus y equals 7, y equals 2x plus 1, same lines. And remember, we thought that they intersect at the point 1, 3, so there is the intersection point. In fact, I've got the red line highlighted. That's the 4x plus y equals 7, 1. So if I highlight this one, see, that is the same point in both lines. So that also verifies that they intersect at 1, 3. Now what we did, let's get rid of that, is we took this line And I'm going to make another copy of it down here. So notice that when I do that, see that line, okay, remember they're color coded. So this is black, this red. The original one was red, and this one, it just made a different color. It's exactly the same line. Of course, it's the same equation, so you should expect that. So what we did, if you remember, I'm going to copy the 2x plus 1, and I'm going to replace the y with it. So notice what happens to this black line. So it actually changed into a vertical line that goes through the same point. The equation of that line, since it goes through the x-axis at 1, is the line x equals 1. See, what Desmos knows without, and maybe you can look at this and see this too, is that the simplest version of this line is x equals 1. So what we did, remember we collected some like terms, 4x and 2x was 6x, plus 1 equals 7. That's supposed to be an equals there. Okay, so same line, just different color. And then what we did was we took 1 away from both sides. It went 6x equals 6. Okay, same line, just different color. Still goes through 1, x equals 1, same line. Okay, so what you're doing as you do the substitution is you're actually getting another line that still goes through exactly the same point. And as soon as you get an equation that has only one variable, it's actually going to be, well, a line that just has x's or just has y's. It's either going to be a vertical or horizontal. And if you remember what we did after that to find the y value, I'm going to put that down here, and I'm going to substitute the 1 in place of x. So notice what happens. 1, x comes up right away. So now it changed that to a horizontal line. That's the line y equals 3 because it goes through the y-axis at 3, a horizontal line. This is actually, notice, has given us the simplest version of it here too, without even evaluating that to get y equals 3. So that's what it looks like graphically as you do all those substitution steps. So let's get rid of all these because we're going to use this again for the second example. And we'll get this out of here. Okay, you did see the second example. There we go. We're back again. So this is a fairly standard system of linear equations. Nothing is already solved for y or x, but the second equation can be isolated for x reasonably easily because it has just a 1x in front of it and for the x term. So what I'm going to do is I'm going to isolate for x. So the 5y is added to the x, so we can take 5y away from both sides. And so that adds to 0, so we just get x equals 18 minus 5y. So what I'm going to do now, I didn't have room to write the equation down, but I isolated for x in the second equation. So I'm going to substitute that in place of x right there. So I'm going to rewrite this 3x plus 2y equals 2, 1. But instead of writing x, I'm putting the 18 minus 5y in place of x. Now this gives me an equation that just has y's in it, so I can isolate for y. So we would distribute the 3 into the brackets. So 3 times 18 is 54. 3 times negative 5y is negative 15y. And then plus the 2y equals 2. Let's collect some like terms. We've got this 54 here. And so let's take away 54 from both sides. I also, at the same time, I collected some like terms, negative 15y and 2y add to a negative 13y. So I'm trying to isolate for y here, so that's why I'm subtracting the 54 to get rid of the 54 on the left. So we'd have negative 13y equals, and this would be negative 52. And then I want to isolate for y. So the negative 13 is multiplied by the y, so we would divide both sides by negative 13. So that divides to give you 1 here. So y works out to be 4. So now that I know that y is 4, I want to find what x is. And this would be, especially if you're checking, it's okay to use an intermediate equation here. This is the most convenient one to find x. So I'm going to put 4 in place of y there. So it'll be 18 minus 5 times the 4 is going to go right there. 5 times 4 is 20. So this is 18 take away 20, which is negative 2. So I think that x is negative 2. So here's my check. So 3x plus 2y is the left side of this expression, and when we put the negative 2 and 4 in, we should get 2. 2 is what's on the right side. So there's my left side expression. So the negative 2 is going to go in here, and the 4 for y. So 3 times negative 2 is negative 6, and 2 times 4 is 8. Negative 6 and 8 adds to 2, which is what's on the right side, so that's good. So let's check in the second one as well. The x plus 5y is the left side expression. So again, we're putting negative 2 in place of x and the same 4 in place of y here. So 5 times 4 is 20. So it's 20 we're adding to the negative 2, which is 18, which is what's on the right side. So it checks. That's good. So the solution is x is negative 2 or y is 4 equals 4, which also means, and I'll show you graphically, that if you graph those two lines, they should intersect at the point negative 2, 4. So let's bring Desmos back again. And so the equations are these ones. So 3x plus 2y equals 2. And x plus 5y equals 18. And of course, remember we think they're intersecting at negative 2, 4. And you can see that right there. That is the point, negative 2, 4. So the first thing that we did was we isolated for x. Remember, we took 5y away from both sides. And so we got x equals 18 minus 5y. So notice that that line is the same as this line. It just covered over it with a different color line. So those rearranged versions are the same line. And they should be. You should expect that to be the case. So then what we did was we took this equation. I'm just going to, so that's the black one right here. So, of course, those are the same lines, so it should be right on top of it. And I'm going to copy this, and I'm going to put that in place of x here. So it just changed that line to a horizontal line, still going through the negative 2, 4 point. And since that goes through the y-axis at 4, we should expect the equation of that line to be y equals 4. So, of course, Desmos knows that. That's why it's giving us the simplest version of that line. So if we, when we expanded, remember 3 times 18 is 54, minus the 15y plus 2y equals 2. Okay, so same line. Remember, we took 54 away from both sides, and we got negative 13y equals negative 52. So same line, and then we divided the negative 13. We got y equals 4. Okay, so same line. So that's y equals 4. And then to find what x was, we took this line, and we put 4 in here. And we get rid of that y. And so it's, well, the simplest version of that is x equals negative 2. Remember, 18 minus 20 is negative 2. So there's the x equals negative 2 line. And so, of course, all those lines still go through the same point. This is really just showing us the solution for x. X is negative 2, and y equals 4 is the horizontal one there. So those two lines really represent the solution, because the equations for each of those are the values for x and y. So that's what it looks like graphically as you do the substitution. And that's the end of the tutorial.